Hello everyone. My name is indeed Alexander Fonarev. I'm going to make a talk on how we can reduce the time to market for AI projects. A few words about myself. I'm the chief data scientist and the co-founder of Rubbles. I have a PhD in data science and engineering. Indeed, I have taught more than 1,000 students in machine learning in Yandex's data analysis school. And before co-founding Rubbles, I spent 5 years in Yandex. Our company, Rubbles, is involved in data science and data-driven solutions for commercial companies. We started with the banking clients, with the banking sector. Now we work with 7 out of 10 largest banks in Russia. Besides banking, we are also involved in retail, telecom, and other industries. As to AI applications in banks, banks have numerous use cases for artificial intelligence. Let me give just a few examples. First of all, you all know that many banking applications have individualized stories and tips. So this is one of the examples of AI applications in the banking sector, because you need to target those tips. You have to process the feedback from the user, likes or dislikes, or the number of stars they give you. Another example is the customization of plans for corporate clients, because you have to both maximize the revenue from these clients whilst maintaining the optimal NPS. The third application is optimizing the reserves on your accounts to comply with the regulators' requirements. So this is where we have huge potential for AI-based predictions. Next, optimization of call center, triage and workloads, or predicting the demand for cash in ATMs, or predicting the optimum call duration. Well, of course, we could set up independent teams to deal with each of those objectives, but could we optimize that even further? So let us go deeper into those objectives, into those use cases, and see whether we can leverage the performance there. So first of all, use case number 1. Individualized communications in digital channels. So we need to engage our customers to ensure the better engagement with the clients. We need to increase the number of touch points with the clients so that they buy more services and products for us. This is an example from Alpha Bank, but our experience in the market shows that such individualized approach increases sales engagement and customer loyalty. Let's have a look at how this can be decomposed into technological components, which can be, after that, operationalized. So what do we need for that? First of all, we need a tool for identifying behavioral patterns of customers performing some transactions, because some customers may have such a pattern as using the bank card to pay for Italian restaurant, or another client may frequently use the bank card to pay for fuel at the fuel stations. And there are hundreds of such patterns. The way it works is that we just trace the frequency of certain transactions. Let's take the often pattern. Let's imagine that some client is performing a certain transaction on a regular basis, or another pattern, the favorite merchant one. We see that over a certain period of time, or over the client's life cycle, this client prefers going to one particular merchant. So this gives us a very useful insight about this client. Another pattern, the state. This is where certain transactions are repeated on a frequent basis. Another pattern, the change. There are many patterns like that, and in the end we have several dozens of patterns that can be used as triggers for communication with our clients. To implement this tool for pattern retrieval from the entire bank card transaction database, first of all, we need a data segmentation module. This module, this tool, has to be developed, coded from the scratch. It's not available open source. What else do we need to do to develop such a personalized service tool? We need a tool for processing names of merchants, because if you have seen the history, if you have seen your card statement, you may have noticed that one and the same merchant may be named in dozens different ways. So here, for example, we see that a certain merchant from the fast food industry can be named in numerous ways. To analyze this data, we need to cluster all those names and assign them to a specific merchant. For that, we need a technical or technological tool, big database tool. This is the module which will cluster those different merchant names and assign them to a specific company. What else? We also need a geo-segmentation module, as we call it, because we need to follow the navigation of the client and their location-related preferences. Also, besides the rule-based targeting models, we also need to implement ML-based targeting models, like, for example, the ones that help us to predict the future actions of the clients, like going to a vacation, for example, which may be associated with the consumption of certain banking products and services. For that, we need to run a series of experiments. Plus, we need a certain ML library which can be applied to a specific task. The models which already have the core attributes, which already have the quality assurance and validation systems, which can be used almost out of the box. And also, since we are looking for individualized approach, we need to perform a series of A/B tests to check that our metrics are still valid. Plus, we need a module for uplift simulation, which will collect the user feedback and incorporate that into our system. So we see that it takes lots of components to create one AI-based application. And all those components can be divided into two buckets: infrastructure tools and business-specific tools, like this tool for identifying or retrieving patterns, behavioral patterns from the card transaction database. So now that we know the structure of this AI-based application, let us have a look at another use case, like, for example, individualizing service plans for legal entities. So here, if you want to maximize the revenue from the client, we may offer them a set menu, and if we're lucky, we will be able to maximize the value and maintain the same NPS for that client. But why don't we try and disassemble this objective? For that, we need to have a payment classifier first. To implement that payment classifier, we need to have all those tools which have already been mentioned in the previous use case description, like the large-scale segmentation module, the experiment base, and the ML collection. Plus, we need a tool for service plans segmentation and scoring, which would give us insights whether there is a positive match between this user, this client, and this service plan. For that, we need large-scale segmentation, we need ML collection, uplift simulation, and experiment database. So we see that there's a lot of overlap with those tools which have already been mentioned for the previous use cases. So it all means that we have a lot of overlap in the tools required for implementing those two AI-based applications, and in the normal world, those AI applications would be implemented by two different departments, but you see that by leveraging the existing infrastructure and business-specific tools, we may significantly reduce the time to market for those AI-based applications. And we have already mentioned 6 components, but you know there's many more. There are dozens of such components which can be reused for new AI applications. We have several dozens of those in our library, and we know from our own experience that it can help you in leveraging your toolkits and reducing the time to market. To sum up, I would like to say that such an approach reduces the time for testing all the data hypotheses, and clearly all the AI-related projects have a very high probability of failure, and this is normal. Many projects and many ideas related to AI, they fail, which is why it's extremely important to thoroughly test them in the shortest possible period of time. The second conclusion is that such an approach allows reducing the time to market. And the third conclusion is that such an approach accelerates the onboarding of new team members. And we see that data scientists are in deficit. There's a shortage of high-quality data scientists in the market. That's why it's extremely important to onboard them as fast as possible. Well, thank you so much. I hope that my presentation has been useful to you. Thank you. Alexander, thank you. Can you tell us what was the reduction for time to market that you achieved on your projects? And so, that's a very good question. It depends. If it's about direct communication with the clients, well, reusing different components may achieve the time to market reduction by 90%, I guess. If it's a totally new task, then we have a reuse ratio of up to 10 to 20%. But even if we don't reuse many of the tools, next time when you have to deal with a similar application, you would be able to leverage on your previous experience. So, as to time to market reduction, well, of course, you have to make a discount for integration and adaptation, but still, if you can reduce it by 90%, that's a lot. For a totally new task, that's up to 10%. But again, next time this task will not be a new one, and you will be able to reuse those tools. And the second question was about our team and how are we able to do so many things with such a small team? Well, you know, we have 100 people. Well, it depends on who you compare with, but we try to hire the best and train them properly. And